Hey, Marcus House with you here. So, as always, a lot to share on Starship development. This has been yet another epic week at Starbase, including a record-breaking preburner and static fire on Starship, but just as interesting is the huge amount of activity outside Starbase. We have Crew 2's return, we have Crew 3's launch, the next batch of Starlink satellites are expected to launch as this video is going live, and this bizarre contraption hurling a prototype in a suborbital flight test. We have Hubble updates with its safe mode and news on the James Webb Space Telescope. Probably best to just get stuck into it. Welcome back to another week of space updates.
Okay, Neal, we can see you coming down the ladder now.
So here we are at Starbase watching SpaceX create the largest rocket ever constructed. This beast will change everything with space exploration, starting just from a pure cost point of view alone. Currently, it costs several $1,000s per kilogram to place something into orbit. This monster vehicle is being made to not only send huge amounts of payload in one launch, well over 100 metric tons at a time, but this is also designed to be the first fully reusable orbital class rocket. If this does what is advertised, that will lower the cost of payload to orbit by orders of magnitude. Each week I aim to keep you updated with all of this astounding progress as we watch this incredible story unfold. Starting off this week, we have the stacking of booster number 5 continuing in the high bay after a few weeks with no major signs of work. Firstly, SpaceX lifted its aft section into the high bay and placed the section onto a booster stand. The bridge crane was then disconnected and transitioned over to the 20-ring high liquid oxygen tank, where it was then lifted up and stacked on top of the aft section. This makes it just one stack away from structural completion. Now, interestingly, this is the first major stacking of Booster 5 in more than 6 weeks, with stacking beginning over 8 weeks ago. In comparison, SpaceX stacked all of Booster 4 from start to finish in about 3 weeks. It's worth noting though that Booster 5 has started off with much more integration already. It is far more outfitted with all of the aero covers, avionics, flight termination system, plumbing, and COPVs than Booster 4 was during its stacking. Keep in mind also that Booster 4 is still not done 3 months after it was fully stacked. Likewise, Ship 21 assembly has also been extremely slow compared to Ship 20, but it's great to see some serious progress this week. To start with, its thrust section was lifted into the mid-bay last weekend, and then early in the week the forward section was lifted on top, completing the stacking of its tank sections. Over at the low bay, its nose cone was stacked on top of the barrel section almost a week ago, and the next night the crane was disconnected, indicating that stacking of the two sections was complete. It's always terrific, I think, seeing the nose cones coming together. This one is looking super clean too, with all of those very precise looking heat shield tiles. Over at the launch facility, the LR11000 crane that SpaceX rented was lowered to the ground and was disassembled early in the week. The sections soon left the launch site on self-propelled modular transporters and then headed to the production site where it was reassembled, rising back up on Tuesday to support the construction of the new wide bay. That has been growing continuously throughout the last few weeks as well. SpaceX's own LR11000 crane with the custom SpaceX branding was raised off the ground on Saturday to install the hook, and then later that night it was fully transitioned into its vertical orientation. This is going to come in very useful from now on. Moving over to the landing pad where Booster 4 is currently sitting, 2 Raptors were delivered, RC-78 and RC-79, which were then installed onto Booster 4, completing its full set of 29 engines. Well, again, exciting updates on the catching arms, with workers beginning the reeving process on the launch tower this week. This process involves pulling all of the rigging through all of the pulleys on the tower and the travelling block on the catch arms, lovingly referred to by Elon as the chopsticks. This is a pretty major step in getting the arms operational, as this will allow them to fully travel up and down the tower. So first, the lead line was pulled through the pulleys, followed by the actual wire rope from the spool at the base of the tower. This wire rope will stay permanently, and the lead line will obviously be completely removed when the wire rope is fully hooked up to the Drawworks winch on the other side of the tower. Awesome work here by Lunar Caveman illustrating this so that we can see it in detail. It's a tad hard to follow the wire rope in the real photographs, but thanks to these diagrams we can see that it will run from the Drawworks on the base of the tower, up and over the top through a pulley block, and then back down on the other side of the tower, running through another pulling block on the arms. From there, it will go up the tower again, through another pulley block, and then back down the tower on the other side into the dead end spool. So hopefully we are going to see some testing action here very very soon. Make sure that you're following Lunar Caveman on Twitter, as there are always great new illustrations dropping. Thanks for supporting all the artists out there, and for subscribing here, of course. That helps us bring all of this content to you every Saturday. The grand finale for this Starship week was of course the first ever static fire with 6 engines. This includes the 3 sea level optimized engines and the 3 vacuum engines. So yes, this was introduced with a preburner test at 11:21 AM local time on Friday. Filling of the black and silver monster started about an hour earlier, then nearly an hour later at 12:13 PM, all 6 engines ignited for about 2 seconds. That is impressive sound right there. Can you imagine what the full booster is going to sound like? It's going to be nuts. So yes, congratulations to the team working towards such a fiery milestone. Interestingly, the amount of frost on the oxygen tank basically covered the entire tank. Quite an unusual sight. I've got no idea yet why that was the case. Maybe they filled the entire oxygen tank, which would be unusual for a static fire. What do you think? In comparison, the methane tank didn't show any of that frost building up. That is quite interesting as well. Once again, a bunch of heat shield tiles were lost in the process, so hopefully Ship 21 will fare better in its tests. Regardless, it was great to see some more epic fire this week. Now, last week we talked about the many delays of the Crew 3 launch due to both weather and medical issues. Originally, of course, Crew 2 was due to return to Earth following Crew 3 arriving, but due to the delays with Crew 3, NASA decided Crew 2 would return before the Crew 3 launch. This was the incredible conclusion to the longest ever mission using a US spacecraft, with the Crew 2 astronauts and Dragon spending 199 days in orbit. As expected, Crew Dragon Endeavour undocked from the International Space Station at 2 PM Eastern Daylight Time and began its journey home. Following a final weather evaluation, Endeavour jettisoned its trunk, performed a 16-minute deorbit burn, closed its nose cone up, and prepared for its fiery re-entry into the atmosphere. The amazing Shane, Megan, Akihiko, and Toma were all strapped in for the final nail-biting plunge into the atmosphere at over 27,600 kilometers or 17,100 miles per hour. During this re-entry, they even screamed right over the Starbase facility in Texas, seen on NASA Spaceflight's live camera feed, which was just awesome to see. The drogue chutes were deployed soon after, followed by the 4 main chutes. Now, one of the main parachutes did deploy a little slower than the other 3, which seemed a little unusual, but NASA did say that it was still inflating at the expected rate, and it did deploy eventually. Kathy Leaders, who is the Associate Administrator for Space Operations at NASA, stated that it is behaviour that we've seen multiple times in other tests, and it usually happens when the lines kind of bunch up together until the aero forces kind of open up and spread the chutes apart. As shared by Arpi, a former SpaceX director, this is called lead lag. With multiple chutes, this is expected to happen on occasion because of the crowding there. And there we go, splashdown of Endeavour into the Gulf of Mexico. Shortly after, they were recovered by the Dragon recovery vessel Go Navigator. So yes, Crew 2 was of course the second mission for SpaceX's Endeavour, which first flew Bob and Doug on the Demo 2 mission last year. As you may have already heard though, the toilet on Endeavour was off limits due to a potential of a leak, like was seen with the Inspiration 4 vehicle. This issue with the Crew Dragon has since been addressed for Crew 3, but yes, the team were essentially wearing an undergarment for waste management, similar to what is used on spacewalks, I suppose. I guess it wasn't a major problem, at least I didn't hear any of the crew hastily calling out to light that candle anyway. Ideally, the toilet will need to be working in future missions. So as the Crew 2 returned home, preparations were in full swing for the launch of Crew 3. Originally slated for a Halloween launch, it was stuck in a string of delays due to a minor medical issue involving one of the astronauts and weather delays as well. But with all of the issues resolved and weather trending the right way, on Wednesday night SpaceX launched NASA astronauts Raja Shari, Kayla Barron, Thomas Mashburn and ESA astronaut Matthias Maurer aboard a newly hatched Crew Dragon spacecraft named Endurance on top of the Falcon 9. This was the 5th crew to launch and the 4th long-duration mission to the International Space Station for SpaceX in collaboration with NASA. These are incredibly exciting missions to watch launch. Just check out that beautiful footage right there. So after launching into an initial parking orbit, Crew Dragon performed a set of in-orbit maneuvers to align itself to the International Space Station. On Thursday evening, Endurance successfully performed 3 final burns and docked with the International Docking Adapter number 1. The incredible crew, of course, includes the commander of the Crew Dragon spacecraft for this mission, that is astronaut Raja Shari. He's responsible for all phases of flight from launch to re-entry and serves as the flight engineer for Expedition 66. Serving as the pilot is the veteran astronaut Thomas Mashburn. He is responsible for spacecraft systems and performance, is the second in command for this mission, and will also assume the command of the station for Expedition 67. Kayla Barron is a mission specialist, along with ESA astronaut Matthias Mauer, also a mission specialist. Now, Thomas is actually the only crew member that has travelled into orbit before, so for Raja, Kayla and Matthias, this was a huge first, and they were of course presented with their astronaut wings, similar to what we have seen in the past flights. So with this launch, there are now currently 10 humans in space, counting astronauts, cosmonauts and taikonauts, all living and working in low Earth orbit. We're living in an amazing era of human spaceflight as more and more countries get involved with sending humans to space. It's also astounding to see SpaceX teams ramp up their crewed launches in the last 18 months, and this is only going to increase in the future with the start of Axiom missions in 2022. So as if SpaceX wasn't busy enough with the Crew 3 launch on Wednesday, the teams on Saturday morning, the morning this video is going live, is preparing for a launch of Starlink after a scrub due to weather on Friday morning. Obviously check that out to see if it did launch or not. Now this mission is launching 53 Starlink satellites to orbit, and it's a special launch not only because it's SpaceX's first Starlink launch in almost 2 months and first from the East Coast in over half a year, but also because it is the first launch of these satellites in the 4th shell of the constellation. So what are these shells, you might ask? Well, think of these as different groups of satellites positioned in a slightly different orbit and inclination to maximise the coverage without crowding up a particular orbit too much. By September 2021, SpaceX had completed the first shell of the constellation as they had launched over 1,740 satellites over the course of the 30 missions. Out of all of those, only 141 satellites were either faulty or deorbited for some other reason. On September the 13th, SpaceX launched the first dedicated Starlink mission from Vandenberg Space Force Base in California. That was named Starlink 2-1, and it was the first launch of these satellites in the second shell. This requires the inclination of the orbit to be 70 degrees. Now, although a second launch to that same shell was also scheduled, it seemed to have been delayed. This next launch is a first of a series of launches to the 4th shell, which will accommodate over 1,584 satellites in an orbit at 540 kilometers and an inclination of 53.2 degrees. Just as with Starlink 2-1, this launch also contained version 1.5 satellites, which includes the laser inter-satellite links. These links are quintessential in extending coverage to high latitudes and mid-ocean areas, and this is because it allows satellites to connect with nearby satellites without needing a ground station. This technology was first debuted on a small number of Starlink satellites launched into a Sun synchronous orbit. They were added to some spare slots on Falcon 9's small-sat program. It's likely that they acted as a testbed for this technology before being implemented on the version 1.5 satellites. Also interesting is that SpaceX updated its Starlink user terminal, which unlike the circular one known as Dishy McFlatface, is now rectangular in shape. Now, other than the lower cost to manufacture and the shape of the dish itself, we don't know if there's any major differences between the original and the new one, but Starlink's website does mention that it is available to all new orders in the United States. Now, another interesting project I've had my eye on for quite a while is the prototype being worked on by SpinLaunch. This is essentially a system that takes a small rocket and rapidly hurls it around a vacuum-sealed centrifuge. Fast enough, in fact, that this travels at several times the speed of sound before an arm lets it go, hurling it out of the centrifuge, where it first punches through a vacuum seal and heads off at blistering speeds. This version here is just a 1/3 scale prototype of the full design, but this concept looks fascinating. The long-term plan is even more interesting. SpinLaunch wants to send rockets to orbit with this system. Obviously, this is not for human flights, just robotic spacecraft and that sort of thing that can handle the ridiculous 10,000 G-forces involved. The rocket is then let go and released at around 8,000 kilometers or 5,000 miles per hour right into our dense atmosphere. Now, usually, of course, rockets use a massive booster stage to get a vehicle out of the atmosphere starting from a standstill. At stage separation, 8,000 kilometers per hour is normally what we would see, but here the rocket is at about 60 kilometers in altitude. At this point, there is basically no relevant atmosphere. At ground though, if you are moving at this velocity, this means dealing with quite a few G's of air drag despite being a very streamlined vehicle. Now, although 8,000 kilometers per hour seems quite fast, quite a bit of that velocity will be wiped off in its way out of the atmosphere, and even if that wasn't the case, it is not fast enough to place it into orbit. For this, it needs to fire up its stage to then accelerate the rocket up to around 28,000 kilometers per hour. SpinLaunch plans for this production vehicle to be capable of delivering up to 200 kilograms into low Earth orbit for the low price of $500,000 per launch. That sounds like a lot, but given that a competitor like Rocket Lab charges a few million for similar payloads, it is actually quite reasonable. That, of course, assumes that the rocket and the payload containing all of that propellant and hardware can handle those 10,000 Gs. I'm a little skeptical given the absurd load on the vehicle and the infrastructure here. That is quite the engineering challenge. What do you think? Is this just kind of nuts, or do you see this becoming a reality in the near future? Now, if you haven't heard, the Hubble Space Telescope again put itself into a safe mode late October. An update on that though, the Hubble team have now recovered the Advanced Camera for Surveys instrument, so positive news there. The other instruments are still in safe mode while the diagnostics continue since the lost synchronization error messages on October the 23rd. Hubble is starting to show a lot of signs of its age now, so how are things going with the James Webb Space Telescope? Well, quite good as far as we've seen this week. It's all looking like it is on schedule for its launch in mid-December, only a month away, so it's getting very exciting. It did arrive in French Guiana to prepare for the upcoming launch on Ariane 5, and that is going through its paces in preparation for the epic mission as shared by Ariane Space early this week. Certainly no pressure there for Ariane Space. This incredibly intricate space telescope has only been an investment of around $10 billion over the 25 years of development. There must be just a little bit of anxiety around this one. Some awesome updates shared around the Intuitive Machines lunar lander as well. While Artemis 1 might launch around February of 2022, another uncrewed mission is awaiting, the Nova C lunar lander built by Intuitive Machines, which will be launching on a Falcon 9. With a launch mass of just 1.9 metric tons, it's able to deliver 100 kilograms of payload to the lunar surface. Intuitive Machines expects this to happen annually from 2022, with larger lander versions being created for future missions. Now, the Nova C will be launched first into a geostationary transfer orbit, and from there it will perform the trans-lunar injection by itself, and that is despite Falcon 9 being more than capable of sending more than 1.9 metric tons to the moon. This alone must mean that the little lander holds around 4 kilometers per second of delta V, and that would be used to finalize the injection, get into orbit around the moon, and then complete a full lunar landing. Now, some of you had some great comments and questions from last week's video. Here we have a big fan of For All Mankind. Thanks for the question. I really loved the two series here, but yes, there was a few bits that I wasn't overly fond of. Just close your ears if you're avoiding any spoilers on that if you haven't seen it yet. So yes, from a Delta V point of view, there was just no way to get the space shuttle from low Earth orbit to the moon and back. That was a strange thing that we saw repeatedly in the series. We also saw landing and launching with the lunar module as a single stage. Not sure what sort of fuel they were using there because nothing that we know of can do that without refilling. In the moonshot video that we released a few months ago, what we did explore was what it would take with Starship to do this same thing. It would be a very complicated mission to make it reusable. You might be interested in that video. It's certainly not something that we'll see in the next 2 years though. Another question here from Chris, wondering why SpaceX doesn't just make a huge single heat shield as a continuous piece rather than the separate tiles that we see. So the tiles of Starship need to be tiles simply because then they can lose one or two of them without it being a big problem. As we've seen, they tend to currently be quite fragile. With a single tile spanning the entire ship made of this tile material, vibrations and slight size changes due to the temperature would break such a thing really easily. That is the big benefit of the stainless steel that SpaceX are using. We see all these planned gaps in this, which gives the heat shield tiles room to expand and contract without breaking. Well, of course they're breaking for now even as heat shield tiles, however I suspect that there are some flaws that are likely being addressed right now. Of course then you have the insulation layer that sits between that and the steel, so that offers several layers to dissipate the heat if the odd tile does fail. Thanks there, Chris. Now, as we've been running over those, you would have noticed these amazing supporters of our channel here. Thank you so much, all of you, for helping to fund what we do, and also to everyone picking up our merch here. Thank you so much for that as well. For the next 3 days, you can actually get this with totally free shipping, which is awesome if you are some distance from the United States. If you like what we're doing and you'd like to help assist us with what we do directly, joining us at patreon.com/MarcusHouse is a great way to do that, or as a YouTube member as well. Patreon does take less fees away, but either way, you will get access to chat with us more directly on our Discord server. You get your names listed right here like these other incredible people, and I release ad-free versions of these videos so that you can watch them before anyone else. Remember as well that I'm always tweeting interesting stuff almost daily, so follow on Twitter at MarcusHouse if you want to stay even more up to date. In the tile in the bottom left today, we have my Mars shot video. In the top right is my latest video, and in the bottom right, a video that YouTube thinks that you will like. Who knows what that means? Thank you everyone for watching, and we'll see you all in the next video.